Hello, in this video I'd like to show you about how we can program ironBCI about software parts. So we have here SDK for mobile application that can be found here in mobile app. It is a mobile application was implemented in Flutter language. All necessary sources you can find if you download this one source. Also, here it's already a mobile SDK for Android that allow you make visualization your mobile phone, save data, and send this data to your via your email or WhatsApp in any comfortable way. So, but of course, in the first you need to read a license since just only as I mentioned is decay. So if you would like change something and implement for your custom project, make some future extraction directly on the mobile phone, you can use already a Flutter SDK and implement your ideas directly on this application. So I just would like to show you how it works. Not over here, probably here. Yes. Not here, probably here. Yes. So it's a mobile application. Allow you install this one application, your mobile phone, Android. Here you have just only need push this one button, connect, and after that already, if you would like save this data and send, after that push this one button, start recording. Before do that, you need push this one button and choose 8 channels since ironBCI operates 8 channels. So it's that's all. So as you can hear, we push connect. This LED indicated for us that communication was established between mobile phone, mobile application, and the ironBCI device. And here also information just was successful connection between devices. So, and here we already can see in real time data from 8 channels. Here I don't connect any electrodes, but anyway it looks like here. So all 8 channels, some visualization via record. Again, you can establish some bandpass filters range, which you would like implement here. But the most important on this mobile application, of course, that you can save data and send already for signal processing for your laptop. And also again, so it's a mobile SDK, you can implement any future instruction directly over here. So this one device also has a few buttons. So first one is, this one is responsible to connect power supply for battery. Second switcher is responsible to provide a power supply already for all device for microcontroller. So to switch is seen that first it's necessary to turn on just only if you would like charge your battery. So you can connect here a USB cable and charge your LiPo battery. Of course, in this case, not necessarily make a connection between all boards. You just only can use a power board. So and let me move forward and come back to our GitHub. So what we have here, it's something that makes sense for mobile applications. And generally, of course, it's 8 channels to connect electrodes located over here, and 1 clips electrodes for BS, 1 clips electrode for reference. And also you can find SDK not just only for signal processing. In signal processing, we already receive already data, but all our registers, especially since we use here ADC 1299 from Texas Instruments. As you know, probably it's this one device has a lot of different types of registers that allow you to establish your custom project. So if you would like already change something here, as example, increase sample per seconds or gain for your inputs, internal gain, internal amplifiers. It's necessary already open software. This one it's from STM microcontrollers, and here already in C language you need just only write some registers that you would like to use. After that, it's necessary already compile this one project, a build project, and create a hex file. if you would like to do that, of course. The next one, here we have a for connection to have opportunity upload hex file. It's for connections, and use this one as the link and connect directly for cable. So it's the name of this connection exactly the same as video, as ground power and clock. So it's right here, and exactly the same connection you can find over here. So it's quite easy upload. So, and last one, it is SDK or directly in Python language. So it means that you can just only launch, turn on, switch on your device, connect a laboratory, and use Python SDK over here. Just only already make some visualization directly on your laptop from your headset. It's also a quite simple script, as we can see here. So this one name of this device, and again, if you would like to change this name, it's necessarily use this one software. You can find a name over here and replace that. This one is always exactly the same. So this function is responsible for our connection. Just only search our right name with name ID and establish communication. This one is it's just only for convert our digital data to microvolts, since ironBCIs and just only bytes. ADC, as you know, it's 24 bits on our digital converter, so it's every time send 24 bits from A channels and also first free 24 bytes, sorry, and also first free bytes. It's just only is information about status. The next one is necessary convert via the next line, so we need just only multiply for this value to convert from volts to microvolts. This one is reference voltage and ironBCI device, so we use a reference 4.5. Here we need divide for this value, it's just only 2 in power 24. It's just only around, as you can see here, to make it much more visible. So we use some buffer, of course, for visualization. The length of this buffer you can find here. It's quite easy also. I indicate here the length of buffer what you would like to use. It's update our buffer. And the next one, it's already just only for reading our information, our EEG data, and make visualization. Here just responsible for plot setup, matplotlib, and here it's quite standard implementation for BLE library. It means that established connection, await some information, and move back. So it's this part's usually it's exactly the same for these types of libraries that we use here. It's PiEEG, quite popular library to implement data transfer between BLE devices. So it's and again we have discard, PiEEG discard. You can define this information on official PiEEG website over here. So something like about here. So PiEEG discard. If you have any questions, so you can directly contact us and provide any feedback about this one device. So, and thank you so much for watching this video, and see you. Bye.